Okay, awesome. So good afternoon. It's great to be here at VS Live. It's a really awesome conference. I was really struggling to choose the talk which to go to, and had a lot of interesting conversations with people. And also, have you guys already grabbed your Microsoft socks? They have them in all 4 Microsoft colors. So do it. I'll wear them to work tomorrow. My name is Jacob Jedrzejek, and I am software engineer at Microsoft, and I work on the Azure portal. You can find more about me on my blog, jj09.net. This is my personal blog. I'm blogging about the stuff I'm doing at work, but also I'm blogging about the stuff I'm doing overnight. And I live in Seattle. I moved here 2 years ago, and it's awesome city. I'm actually every day exploring it, one weekend at a time. I especially like hiking a lot. There's many good places to go. So if you're guys just visiting, take one day and go out somewhere in the area. Strongly recommend it. I'm also doing triathlons, and here again, a lot of lakes. It's awesome. So triathlons is swimming, it's biking, and it's running. I recommend to do it for everybody because, you know, we software developers, we sit all day, so it's sometimes nice to go out there. But every day I work on Azure, and I think this is the official Azure color. And this is, by the way, the Azure coast in France. And I work on the project code name Ibiza. This is Ibiza Island in Spain. And this is the Azure portal, the new Azure portal. I believe most of people have been using it here, right? Who have been using the Azure. Okay, so like most of people, awesome. So have you guys seen that if you do F12, we have this ASCII arts at the bottom. And what's even more, like there is a link with a job offer there. So if I go to the Azure portal right now, portal.azure.com. It's loading. Amazing Fisting Cloud. By the way, I have some stickers, so you can grab it after my session. And I do F12. So somewhere here, there's this cool ASCII arts, and if you click this, aka .ms/build this, you'll get redirected to Microsoft Careers, and you can apply for a job at our team. Or you can just talk to me after my session. I'll save you like 3 months of the recruiting process. And I just recently switched to awesome dark theme in F12 tools. You know, you can do it here in settings. You don't need the plugins anymore. So here, there's dark. It's awesome. And you probably also noticed that I have a portal in dark theme. And did you know that if you double click here, you can change the theme? So you can have it blue, you can have it dark blue, or you can have it light. I prefer the dark. I think it's the coolest. And also recently, we introduced the multiple dashboards. So this is my default dashboard. But for example, here, there is a drop-down, and I already have created the dashboard for my blog. So jj09.net dashboard. And here I have stuff related to my blog, requests, errors. Here there's my database, alerts, so on and so forth. And what even more, you can share the dashboards. So for example, here, I have .NET Conf PL dashboard, which I'm sharing with my friends. Sorry. And if you click here, you can manage users. I need some drink. Sorry. So here I am sharing my dashboard with all people who has access to my subscription and are subscription admins, and they can see this dashboard. They can do modifications here. So for example, if I move something, then I can say publish changes, and it will be reflected to all of my friends' dashboards. I won't do it now. I'll just discard them. And another cool stuff in the Azure portal, let me switch back to my dashboard really quick. So my dashboard takes a little bit time to load because I have a lot of stuff here. So, you know, this is a insights, a lot of charts. It's a few requests to get all of these metrics. So more stuff you have on your dashboard, the more time the portal will take to load. We also have a keyboard shortcuts. So if you click a question mark, here on the right-hand side, you'll have a list of keyboard shortcuts. And let me open the Karnak tool. Karnak. So Scott Hanselman told me about this. It's pretty cool. So it will display every keyboard shortcuts I click. So for example, if I click N, it will open the new blade, and then I can search, let's say, for WordPress. Click Enter, and it will give me a list of already pre-configured WordPress websites or virtual machines. Another shortcut I really like is if you hold the G and click A, it will go to all your resources. So for me, it's faster to click G8 than just moving my mouse and click here, all resources on the left bar. And by the way, you can collapse the left navigation bar. There are also settings here. Not many people know that. There's some stuff like you can disable animations, then Portal will go faster. You can hide and show command labels. So for example, if you are in a web app blade, here you have on the top, you have commands, but if you click hide, it will disable them. And some people think it's cooler. I like them here. So this is a brief overview of the portal. And like recently, I started doing a series of like short videos about some hidden features of the portal. Let me close the Karnak really quick. Because there's a lot of features like that, but people don't know about them. So if you go to my blog, here I have Azure Portal tips and tricks posts. So here you can check stuff like themes or customizing dashboards or keyboard shortcuts or organizing your blades, because you also can customize blades, or how to work with journeys, so on and so forth. Every video is up to 5 minutes, so it's very short. I encourage you to check it out. So going back to Azure Portal, again, if you're interested, click and apply or talk to me. But what we are mostly doing on the Azure Portal is just working on the front end, exposing the entire Azure infrastructure to you, so you don't have to worry about all these hidden complexities, because entire Azure is super complex, and the number of layers that you're going through when you're saying, please create new virtual machine for me, is really, really high. A quick fact about the new portal. We have over 500 developers working on front-end only currently, and we have almost 100 services available on the portal. Yes, 100 different services like websites, virtual machines, SQL, DocumentDB, so on and so forth. I remember when I was starting at the portal 2 years ago, it was something about 15, maybe to 20. So now we have 100, and we have over 2,000 blades, which is equal to a view of the standard page. And the problem we had with the old portal, where there was like 20 services there, we already had a scalability problem with managing only 20 different services and deploying, because at that time there was 3 weeks sprints, and we had to wait for every different feature of the portal, like websites, like VMs, like SQL, that they will do their own changes, and so we could deploy together, right? And then it was getting slower and slower after every new team was coming. So that's why we created a new portal, and we changed the architecture. So in the old portal, we had only one monolithic front end, which most of the applications have. But now, we still have of course, our core of the portal, of the website. And we also have a framework running on top of the website. And my team actually is responsible for the core of the portal and the framework. And framework talks to website. And using framework, the different features of the portal, like web apps, like SQL, communicate with the website. So they are not directly deployed inside the website. They are deployed separately. So every different feature on the portal can deploy whenever they want, as long as they use our framework. And every feature works in a separate iframe. And for example, web apps is one iframe, and they communicate using the framework with the website. The same with virtual machines, and the same with SQL. And what is interesting about that is that this code is only JavaScript. There is no view in these iframes. So we just load the JavaScript, and using view models communication with the framework, the extension, because we call it extension, because that's like extension for the portal, they communicate using post messages with the website, saying, for example, like, okay, display this website, and here are the information you should load to your blade, and we have common set of APIs how this communication works. And here is a more high-level architecture of it. So we have the website that have this API using post messages with hidden iframe. So here is, for example, TFS extension is one of our extensions. And then they have their own web server. And this web server is using public Azure APIs because I don't know if you have known, but all Azure APIs are public, so you can use them. You just need to obtain Active Directory token, and you can communicate. You can build your own client. You can even use the Fiddler to deploy VM if you want to. And then this public API talk to some underlying services of the Azure, and they talk to, for example, actual VMs. They create VMs, so on and so forth. And then on the portal side, on the portal server, we have extensions config file, where every extension gives us the URI to their own endpoint, and we just load the extensions. And if you go to portal, go back here, let me close up this for a while. So if I click Ctrl-Alt-D, you'll get debugging information. And here on the right, you can see what different extensions are being loaded, because we don't load all 100 extensions because there will be a bunch of JavaScript. So for performance reasons, we just load extensions that we need. So Hubs extension is the core extension of the portal. It's the sidebar and navbar and dashboard. Websites, of course, the Azure Compute is actual virtual machines. Here's a classic storage, App Insights, billing, and insights, which is the monitoring data. And we also unload every extension when it's not being used. Like here, all the extensions are loaded because they're being pinned to my dashboard. So again, if you want to have your portal fast, don't add much stuff to your dashboard. Okay, so we use TypeScript to build our front end. We also use Knockout.js, which was created by Steve Sanderson. He was working with us for almost 2 years, so that was a great help, especially when we needed some feature in Knockout. We also use jQuery, like everybody today, to do some DOM operations and just don't optimize JavaScript per browser. We use Require.js for module management and async loading. We use D3 for our charts, so all these beautiful charts on the dashboards are based on D3. We use some features of HTML5, like we have a local storage. We also use the less. Less is transpiled to CSS later on, and it allows you to create mixins and then variables that you can reuse across different style sheets, because we have, of course, a lot of styles in our code base. For unit testing, we use QUnit, which is pretty good testing frameworks. We didn't encounter any blocking things. It doesn't have the mocking framework, though, so we are using Sign-on.js to do mocking. Sometimes we do manual mocking, but most of the time we are trying to stick with Sign-on.js. And on our backend, which is like our server, not the backend of Azure, but the server that exposes our front end, we use C#. We have ASP.NET MVC5 website. And we also are using Node.js. And this is interesting because like recently we figured out that all the extension code is actually logic. And what happens on the extension side is something like when somebody is trying to create new virtual machine. So then the extension is doing a call to Active Directory. Can this user create this resource? Then it's doing call to billing. Can he do it? Does he have a credit card in? Does he have enough credits? Then can you create this in this region? So it's like multiple calls to different APIs. So figure out that we can move this to the server and then do all this logic on the server side, and then using WebSockets, we can communicate with our frontend. So then you will issue the message and all the logic will be happening on the server, and then only the resulting message will be coming back to the client. So we are experimenting with that. We are flighting this. So sometimes you might notice in your URL, if you have feature.relex, that's what we call it, or relocatable extensions. So if you have this, that means you're running Relex and it's Node.js backend. We use Visual Studio unit testing framework for our C# tests. In C# we mostly have UI tests using Selenium framework. And we also use Mock.U to mock, but we don't mock too much because we don't have any actual business logic in our front end. So this is how many lines of code we have in our code base. So actually this was true in January 2016, so this snapshot was 6 months ago, and you can see that we have over 800,000 lines of TypeScript. The JavaScript lines is compiled TypeScript, so this is not written by us. The C# code is mostly the Selenium tests, and you're probably curious what's the state today. So I just, before this talk, I just ran the counter towards our current code base, and it turns out that we just achieved 1 million lines of TypeScript. Not sure if this is something to brag about, but this shows like what kind of challenges do we have when you have so much code in there, and you need to be able to develop, right? And what TypeScript is helping us with, so let me open the console, is especially exposing the APIs. So let me make directory tstmp, and let me open Sublime Text. Yep. So if you have some simple TypeScript, let me create a new file. Let's call it api.ts. So here, let's say I have a function called hello, and it takes first name and last name. And this function is just logging to console hello space plus first name plus space plus last name. I'll save this. This is a JavaScript, but at the same time it's also TypeScript, because TypeScript is a superset of JavaScript. So every valid JavaScript code is also valid TypeScript code. And I will compile this. I have a TypeScript extension in Sublime, so I just do Ctrl-B and compiles my code. And I'll open a TypeScript and JavaScript side by side. Make it a little bit slower, a bit smaller, okay. So here, you can see that actually JavaScript is the same as the TypeScript, right? Because there's no TypeScript in here. But what I can do here, I can add types. So I can say I want first name to be string and last name also to be string. And then when somebody is using this API and they are saying hello, and for example, I say Jacob Jedrzejczyk, and I'll compile this. You still see that on the right-hand side now I don't have these types. So only TypeScript know about the types, but on the runtime the JavaScript doesn't need to know that, right? Because nobody will be changing the resulting code. And then I can run it. I have a Node plugin as well, and you can see it's printing out hello Jacob Jedrzejczyk. So now in JavaScript world, what can potentially happen is I can say just print me this, right? This will compile. And then, on the runtime, you might not even notice that you'll print Jacob Jedrzejczyk undefined, right? Because you don't even have an error being thrown. But if you try to do the same thing in TypeScript, you'll get the compilation error that's saying that your parameters doesn't match. But this is not usually the case, that you're just changing how you call the method. The usual case is that this is being written by one developer, and this is being written by another developer. And someday, like developer one has this awesome idea, I'll improve this method hello, and instead of having first name and last name, I'll just require person here, and I want to have person.firstname, and I want to have person.lastname, right? And whenever I am using this code, I will do hello, and I will specify first name, Jacob, and last name, Jedrzejczyk, right? And this will be totally fine, but here in TypeScript Word, you get red squigglies. So the developer one who didn't know that the developer two who didn't know that developer one changed the code will get compilation error, right? So if I try to compile this, I'll again get the error that the parameters doesn't match. And then you can go back to the method and you see, okay, this guy requires person. But then, again, TypeScript will help you to strong type this, because you see there's one parameter required, but what this parameter is about. So in ideal TypeScript Word, you'll say, I want this person to be person type, and I can specify the class, which is person, which has first name, which is a string, and has last name, which is also a string. And then I get red squiggles here. Let me remove actually this hello, because I don't need this. So developer 2, again, or even developer 1 who changed the API, he's getting red squiggles that, oh, the code written by developer 2 will crash here. Okay, so I need to fix this. So I need to say p new person, p.firstname equals Jacob, p.lastname equals Jedrzejczyk. And here I'll provide a p as parameter. I'll compile this. Here everything is fine, and I'll run my JavaScript, and everything works. I didn't break anything. You can also create a constructor. You can say, I want a first name, which is string. I want a last name, which is also string. And then here, I'll say this first name equals fname. This is very nice IntelliSense in Sublime. This is an official TypeScript plugin, actually, created by TypeScript team. So now I have constructor, and now I can say new person, Jacob Jedrzejczyk. And remove this. I compile this, and I run this, and everything is still working. I can even go a step further with TypeScript. I can move this method to my class, because actually I am just using properties of class of the person. So I'll move this here. I'll indent. I can remove the word function. Actually, I have to remove. I also can remove the person parameter, because I will use this instead. Say this and this here. And now instead of saying hello p, I can say p.hello. And then again, I compile this, and I run this, and I have the same effect. So here, TypeScript is helping me to control the code. And another nice thing about the TypeScript, if you take a look at the left-hand side code, and if you look at the result JavaScript, this is starting to be messy, and it actually is getting messy when you do, let's say, developer extends person. So now I'm doing inheritance, and I want to add another property, for example, skills, and it can be an array of string. And if I try to compile this, I'm starting getting a lot of JavaScript code, right? So now on the left-hand side, I'm using ECMAScript 6/7 because TypeScript is compliant with the ECMAScript vNext, which is now renamed to ECMAScript 2015 or 2016. And on top of that, you have types, which are optional. So now together with Babel, TypeScript is the leading transpiler of ES 2015 or ES 2016. And again, in a large-scale project, it really helps, the types checking especially, and it gives you some sort of free unit tests towards your code. Okay, let me go back to presentation. So that was 2016. Now we are over 1 million, and this is only the 1 million lines of TypeScript is only on the core of the portal and the framework. Every 100 extensions is additional lines of code. So we have something probably like 5 million in total, or even more. So if you want to learn more about TypeScript, I recommend you to check out my YouTube channel. I did 2 talks last year, one about building large-scale web applications with TypeScript, this sort of one-of-one of TypeScript, how you can compile TypeScript, how you can create a gulp task that will do compilation in the background automatically for you on file change, how you can use existing JavaScript libraries using type definitions, and how you can sort of create end-to-end small app. Another one, TDD with TypeScript, Angular, and Node, is how you can use TypeScript in your existing Node.js or AngularJS applications, how you can test your code using frameworks like Jasmine or Mocha. So I encourage you to check it out. So going back to the portal and the challenges we have. So our first big challenge is to enable over 500 developers to work on one code base. And few things that we are doing to make it better, make it smooth. First thing, we have a tool called CoreXT. It's internal Microsoft tool that is ensuring that every developer will have the same environment to run and compile your code. So what CoreXT is doing is just command line tool that is installing the same version of C# compiler, the same version of TypeScript compiler, is using the same .NET framework, and is setting your environmental variables. So for example, if I'll go back to my machine here, when I'm opening new command line, I have start.cmd script, and it's setting all my variables, and it's making, oh, you cannot see it, sorry. I need to, where's my presentation? Okay, here it is. Okay, now you'll be able to see it. All right, you're back. Okay, so I open new tab, and it's setting up all my environmental variables. It's checking that I have all the packages that are specified in the config files, and then I can run the builds from this, and I have the same the same environment that I will have in production. Yes.
So for those of us that don't work at Microsoft and don't have access to CoreXT,
Yes. So you can. Yes.
PowerShell scripts?
I would suggest go with Vargant and Packer. So that's the tools that people out of Microsoft are mostly using. So it enables you to create virtual machines straight from the config file. So you have one config file for your entire team. You use Packer to create your virtual machine, Packer and Vargant to create your virtual machine image, and then you can run just this virtual machine, and all folks will have the same environment, even disregarding your local installation. Another thing we are doing is code reviews, because when you work with large code base, it's not possible that you'll know everything about it. There are still areas I am finding out that they even exist every day. And code reviews is a very good way also to learn about the code. So in our team, every code that is being pushed to production has to have usually 2 sign-offs, so at least 2 people will check that it's fine and give you some feedback, how you can do it better, or just make sure that everything is fine. When we have like small changes, we just require 1 sign-off, like for example, if you change some 1 line of CSS. But you still should have this, because you might think that, oh yeah, just 1 line, right? What can happen? And then somebody else can tell you that, oh, but you know, like recently you have discussions about this, that we are actually changing our approach. Actually, this will break a lot of stuff. So it's very useful. a lot of people says that it also takes a lot of time, right? Especially when the code review is large, right? You get like 100 files, and please do code review for me. So in these cases, what I'm usually doing, I'm just going personally to the person who sent out the code review and just talking to them and, hey, can you do the code review together? Can you like tell me what you have done here? What issues did you have? Because like by reading code, you don't know what problems the developer had and what decisions he had to make during this process. So then he can explain you, and you can get a better understanding, and you can still learn. Just before my talk, we had a discussion about the source control, and I don't know how many of you have been using TFS ever. Okay, like half of the room. How many of you like how the branching works in TFS? Okay, I don't see any hand, right? So especially branching in Git is awesome, because Git it's different than TFS, that when you do branch, it's just doing the differences. So TFS just creates a copy of your entire repo. So if your repo is 100 megabytes, you try to create a branch in TFS, you have 100 megabytes of another, of the same files basically. And then you change one file and you have 200 megs, it's not necessary. Git is doing just differential commits. I cannot spell this word, but you know what I mean. And then you have just one file with differences, and you can merge, you can easy rebase, and you can commit locally, which is also another big advantage. And you can have 100 or even 1,000 private branches on your local box, and it's totally fine. We also have continuous integration, of course. We use Jenkins for this purpose. And what we're doing in continuous integration, of course, when you push the code to our dev branch, we run an official build, and then we run our test suite. So unit tests, integration tests, UI tests, some infrastructure checks. And we also, what we are doing, you can see here on the top, today's CI rep. So every week, somebody else from the team is our continuous integration representative. So he is making sure that our board will be green, because we didn't want to punish one person from the team saying like, okay, that's your job forever, that you'll be just making sure that this is green, and if somebody will break it, you will go and catch them, and you'll be pain in the butt for like entire team, and everybody will hate you. Instead, we have like rotation. So every week, a different person is CI ambassador. And if you break the build, that's what happens on your desk. And if you break the tests, we have this. And that's actually my desk, which is unfortunate. And so we have this dev branch, and once we push the code, we run the tests, and then when our CI board is green, we merge all our changes to the dogfood branch. Dogfood is like our internal staging environment, and we do deploy to our dogfood/staging, and then everybody from other teams can access it. So this is like fully automated process. And then we also have AMPAC branch, which stands for ms.portal.azure.com. This is where we redirect all Microsoft employees and MVPs. So they have like a little bit newer version of the portal before it hits the production. And currently we manually merge the changes. Every Thursday, we merge all our changes to AMPAC branch. Plus we do hot fixes all the time, but usually every Thursday, and we do deploy. And then we also have production branch when we merge the changes every Tuesday. So this is currently manual process, because we decided to do this manually in order to be able to measure some performance metrics. So we do some deploy to AMPAC, and then for 2 days we are looking at the performance metrics. If some metrics is going up, the load time is very bad, we just revert the change and we investigate before deploying this to prod. So speaking about the performance, that's second biggest challenge, because if there's 500 developers, everybody is adding more code to your code base every day. A number of features is growing. And then, of course, in Azure, we have growth almost 200 percent every year. So your number of users is also growing, but you want to keep your load time the same or even go down. So here I have a few performance tips I learned over 2 years working on the portal. So first one, trivial, just minify your JavaScript. Hope everybody is probably doing this. Tip number 2, minify your CSS. You can save up to 70% of network load with this. Thing number 3, lazy load your JavaScript. So don't load your entire JavaScript on the startup, because usually in the startup you don't need most of the logic. You just need the logic when user interacting with your website. And this is especially in case of single page applications. You can also lazy load CSS, because sometimes CSS can be a few megabytes. Why load all of them at the start time again, right? Another thing, bundle your JavaScript. So for example, when in the portal, when you open the new Blade, right, we load some Blade.js file. We also load some tile.js because Blade has tiles. We also load command-bar.js. So we can bundle all of these JavaScript files. So now browser can do only one request to get them instead of 3. Because with HTTP1, you can only do 6 concurrent requests to the same domain. Browser doesn't allow you to do more. So you can do 6 requests. You need to wait a few milliseconds once they come back and then do another 6 requests. So bundling helps here. And the same in case of CSS. Also bundle your CSS the similar way how you bundle your JavaScript. Tip number 7. Cache your JavaScript as much as you can on the client side. And there are 3 things that you can use in order to achieve that. It's e-tags, cache control, and unique URLs. So what is e-tag? E-tag is sort of checksum of the file that when a browser is doing requests to the server, they can say, hey, I want this file, and this is the e-tag of the file I have cached, and if the file on the server changed, please send me the new file or just tell me that it didn't change. And cache control is saying like, how long should I be using this cached file? So for example, if you set cache control for 1 day, I'll be using my cached version and be checking the e-tag after 1 day. So for first 1 day, I'll be just using my cached version. Then after 1 day, because this is like 2 requests. If I want to use e-tag, I need to do first request. Okay, this is my e-tag. Should I do this? Say, oh, I have new file. Okay, send me new file. But when you have cache control, for 1 day, I just know I'll be using the file I have cached. And then you might think, okay, so for 1 day I cannot change anything. If I'll do some change, then I will be to waiting 1 day, right? So then you can use unique URLs, because unique URL, when you change something, you create new URL to your file, and then this file, of course, won't be cached because you didn't download this yet. So then unique URLs will give you a new file. So in combining these 3 different techniques allows you to take advantage of as much as you can of the browser caching. And there's a very good article on Google. Let me copy it over here. The developers at google.com. I really encourage you to check it out. It's talking about how to use e-tags, how to use cache control, and here on the bottom they have sort of the caching checklists about what you have to do to accomplish the best caching strategy as you can. So here's the link. If you want to, you can take the photos now. Really recommend you to check this out. It's good stuff. And going back to more tips. Tip number 8, cache your JavaScript and CSS on the server side. So for example, we sometimes are doing bundling on our server. We actually don't pre-bundle. You might do pre-bundling, then you don't have to do this. But if you're bundling on your server, then cache this as much as you can, because probably many clients will be requesting the same JavaScript or CSS. You can also, cache as much as you can the local variables on the server side. That's another thing to do. And after my session, Jason Bock has a session about .NET performance. So I recommend you to check this out as well. This probably will help you also with optimizing your server code. Another tip, use CDN, Content Delivery Network. So how CDN works, for example, if you have your website deployed in US and somebody from Europe requests your website resources, especially static resources, they need to go all the way to US to get the content. But if you take advantage of CDN, which is distributed all across the globe, and then the person from Europe will go to some European CDN and will request the resource. If resource is present, they will get it right away. It will be much faster than going all the way to US. If the resource is not present yet on CDN, CDN will do a request to US, will get this resource, will cache it, so all other users that will request the same thing in the Europe CDN will get the cached version. Another tip, use gzip compression. So like recently I ran this tool, gzip check gzip compression. So I ran it towards my blog, jj09.net, and because I'm hosting my blog on the Azure websites, which enables gzip compression, and you can see that I'm saving almost 80% of the size thanks to gzip. So uncompressed size is almost 37 kilobytes, and compressed is less than 8. So that's a big gain, right? When you can request like 1/5 of what you would have to without it. Another thing that we are doing a lot is using SVGs instead of PNG files or JPEGs. And we also are bundling them. You can think about this as a sprite, but SVG is just a text file, right? So you can bundle all SVGs, like you bundle JavaScript, like you bundle CSS, and again have only one request to your site to get them. And SVG can of course scale, so you don't have to have low res and high res images like you would have to have with PNGs. Of course it won't always work, because when you want to expose some picture you cannot use SVG. SVG is especially good in case of icons and things that are being able to represent as SVG. Another tip might be a little bit surprising, but if you use HTTPS, you actually can be faster than if you're using HTTP. And at first I was thinking like, how is it even possible? And then Troy Hunt wrote this blog post saying and explaining why. And I really recommend you to check it out. I wanna go fast, HTTP massive speed advantage, troyhunt.com. So there is this website, HTTP versus HTTPS. And here you can check out how fast has 360 requests to HTTP. So here I have 5 seconds, a little bit over. Now I'll be using HTTPS. And now I'm faster by 80%. So how this happened, right? So here you can go back here at the bottom. You can see that HTTP are using HTTP 1.1, but HTTPS are using HTTP 2. So you might say, okay, that's not fair. Why you don't use HTTP 2 versus HTTPS 2, right? But the thing is, again, in Troy's blog post, if you go to can I use, and you search for HTTP 2, you can see that all the browsers has this annotation 2, and this annotation is saying that it only supports HTTP 2 over TLS, which means you can have HTTP 2 only when you're using secure connection. So you cannot really take advantage of HTTP 2 when you are using HTTP, not HTTPS. And here in this blog post, like he's showing how looks HTTP request versus HTTPS. So it's much faster, and especially if you have a lot of resources, this way can speed up your performance too. And the last tip, of course, write performant JavaScript. A few things here, caching variables and functions. and minimizing DOM operations. Of course, with DOM, it's easy to say, right? But that's what you're doing in JavaScript. Usually, you add new DOM elements, so on, right? But there are some, for example, in jQuery, some methods like show and hide, which turns out to be very expensive, and it's better to use just class with display none property on it than to use show and hide, because show and hide are doing checks, like, for example, has this element display none already, so I have to save it for future when you will trigger show on it later on, or it doesn't, or maybe it has some classes that I have to override with import, and it's doing a lot of computations unnecessary. And going back to caching variables and functions, so here I have this small chunk of code, unminified.js. So it's really small. So here I have some object, my application, which has properties, which have general user settings and layout, show labels, disable animations. Let's say it's some portal settings. And here I have a code when I am using it. And here I am just checking for the layout. So I'm using all this deep location of the property, the same here and the same here. And if I'm doing this, the minification will not help me. So if I take this code and I will go to some JS minifier, say JS compress. I'll paste this code. I'll say compress JavaScript. And you can see that here I still have this long names, right? And if I get this code, and here at the bottom you can see I have 344 bytes. So what you can do here, which will be performant from two reasons, that we will not always have to do the deep lookup here for the user settings, because this is actually what I'm using. I can say here var user settings equals, and I can copy all of this, paste here, and just reuse the cached object. So this will save lookup plus the bytes. So now, if I compress this code, and so here we have 344 before I cache these variables, and now after, now after we have 40 bytes less. But that was very trivial chunk of code. If your code is like more complex and you do more deep lookups, you can save even more bytes. And again, it also like looking up the object and getting the nested objects is also expensive. So that was another tip. But I also, last night, I put up this small website. So here I have require.js, so I'll switch here, and I'll run the HTTP server, saving at 8080. I'll go to localhost 8080. Save a very simple website when I have just one button, get people. I click the button, I'm getting the list of the people, and every person have a video associated with them. So if I click a video, Steve, it loads the video. It's using video.js plugin, so I have a nice player. So here I'm playing a video. Here I can click on the screen, I can stop it, which the standard HTML player doesn't have that. But what you can see here, actually before deep dive there, let me open this in code to show you the code. So I'm using Visual Studio Code. I'm starting liking it every day. It's getting better and better. So here I have my index.html. And in the index.html, I have just this button, get people. And here I'm using jQuery, I'm using _JS and video.js plugin. And my app lives in app.js. So I go to JS, app.js. So here I have a click handler, getting people, and just generating a list of people. And here I am using underscore to get the size, and here I'm using underscore to iterate over array and attach the people to the DOM. Of course, I don't have to use underscore, but for the demo purposes, I am. And here, once you click on the video, it's attaching the HTML player, and it's loading the video.js plugin on it. But what you can notice, if you go back here, and if you go to the network tab, and you refresh this, I have disabled caching. So you can see here that I am downloading 1.1 megabyte at the start, and I am loading both underscore and video.js, which I am not actually taking advantage of, because as you can see here in the code, like I will be using underscore and video.js after I will do the click, right? But first thing first, if you look at this, how I load synchronously all my dependencies, this can become messy when, for example, this is, again, easy code, but if I move this here, right, the application will stop working. If I request new, it doesn't work, right? That's because the jQuery was not loaded when the app.js was loaded. So I need to manage this by myself, but I can do it better. I can use require.js to manage my dependencies. So what I will do here, I already have require.js here, and I also have the config file for my require.js. And in this config, I am saying that my base URL is JS, and I have passed to jQuery is jQuery 3.1.0, underscore is just called underscore, and video.js is called video.js. And here I am loading my app module, so this one file. But before I'll be able to use this, in my index.html, I'll add a script with js/require.js, and I'll get rid of this. And in my script, I will say data main equals js/config-require.js. So this will say require.js, hey, this is my config file, use this to bootstrap my app. So then, if I go and refresh, I'll still get this error because I need, in app.js, I need to load the modules I'm using. So here I'm using jQuery and underscore and video.js, but I didn't load these modules. So I need to say require jQuery underscore lowercase and video.js and create a callback function. I'll use $, I'll use underscore and video.js. And now I'll move all this code inside this callback, indent, save this. And now if I refresh that, click get people, and here everything is loaded. You see underscore and video.js is loaded, and also open the video. So everything works. And you can notice that here, now I am loading it in stages. First, I am loading my CSS for video.js and require.js. Then I am loading my config file. Then I am loading my app. And then I am loading underscore video and jQuery. But here now I have 1.2 megabytes. So, you know, my startup code even grown, right? So what I can do, very first thing I can do here is minify my code, of course. So I already have here the gulp file, gulp.js, with two tasks, minify CSS and minify JavaScript, okay? So in my config require, I'll change my base URL to dist/js, because here in a gulp file, I'm outputting my minified JavaScript and CSS to dist folder. So I'll change this. And I will also, in my index.html, I will say dist/js/config require and dist/js/require.js. I'll save this. I will run my gulp, which will do the minification for CSS and JavaScript. Okay, so task is running. It's minifying CSS and JavaScript concurrently. And now it's minified, and now there is this directory. So if I go back here now, I request this. Now we can see here on the bottom, I have only 437 kilobytes. So I saved over 60% of my initial load time. So it's getting better, but we are still quite not yet here. Because, you know, at the initial load time, I don't really need this underscore and video.js, as I mentioned, right? Because I'm not using them until I click on get people. Then I'm using underscore So I can defer loading of underscore and video.js. So let's do this. So I'll get rid of underscore and video.js here. I'll remove them from here. And I'll require them in here. Function underscore and video.js. And I'll grab this code, put it in here. I'll run gulp to minify my app.js file. Now I'll Control F5, and you can see that now I have only 140 kilobytes. So I have over 80% less code at the startup time. But then still, like when I click get people, I'm still loading underscore and video.js, but I'm still not using video.js, so I can defer it even further. So I will do the same for video.js. I'll just remove it from here, and load it after I click on the video. So I'll say require, function video.js actually. And I'll move this code in here. Save this. And I'll say gulp minify JS, because I don't have to minify my CSS because I'm not doing anything with them. So I'll just minify my JavaScript. And if I refresh now, I have jQuery loaded here. I click get people, underscore loads, but not yet video.js. And I click video, and I have my video.js loaded. So I'm still doing better at the very beginning. I have only 149 kilobytes. But you can also notice that I am loading the CSS here at the beginning, which are not really needed at the beginning. I just need them when I will be using the video.js, right? So I can defer that too. And in order to prove that I need the CSS, so I'll remove them. And if I refresh that, click get people, click video, you can see my player doesn't look good. So I need this file. And how I will get it? Here, once I click on video, I'll say head, append, and the stack. I'll just escape the quotes. Click save. And I will minify this file, run my minify.js gulp task. And clear this, Control F5, and now I have 105 kilobytes. So I have 10 times less startup code than I had at the beginning. You remember I had 1.1 megabyte. Now I just did minification of JavaScript and CSS. I am loading them asynchronously when I actually need the modules. And I'm also deferring the load of CSS. So to make sure it works, it's still there, video is still playing, I can click, it stops. So summarizing this performance thing, I think we applied every possible performance optimizations we could. And what we are doing now is basically just trying new things. So we are doing some change, then we have a metrics measuring whether this change helps with performance or it hurts our performance, and then we revert or we leave it, and then we do another change, and we again monitor it, see if it improved the performance or at least didn't hurt. We also use a JS perf in our CI. We started using the performance tests. Like for example, in our grid, we have tests such as load 100 items to the grid and see how much time it will take. And then you might do some change that you think doesn't interact directly with our grid, but decrease the performance by 80%. And then, like recently, I think it turned out we add some focus management logic to our grid that decreased the performance by 60%. And thanks to our JS perf tests, we were able to detect this. So talking about the regressions. So that's what happens to probably all of us when we think that, yeah, we'll do like one small change, it will not hurt anything, but then it turns out that there's this waterfall of bugs on us causing by this one small change. So, yes?
Question for you.
Sure.
For like the minification, et cetera, you know, using gold, et cetera, that all makes sense. But you had mentioned before that you have a dog food branch, et cetera. Anywhere in your chain, do you have the non-minified JavaScript and CSS for debugging purposes?
So the question was whether we have a possibility to run unminified version for debugging, and the answer is yes. And actually this is pretty interesting to show. So if you go to the portal, so I do Control F5 now, so you can see the load time will be around 5, maybe to 6 seconds, and this is running the optimized minified code. Actually you can see the load time if you do Control Alt D. Here there's a portal load time is 5.4 seconds. But if you take portal.azure.com and you say client optimizations equals false, optimizations, now it will load not bundled, unminified JavaScript and CSS. So that's how we can do debugging. We have this in our all environments for dog food, for MPAG, and for prod. And probably we'll have to wait until the end of this session until this loads, because if you do F12, you can see that all the files are, like all our view models are being loaded separately. And you can see here 300 requests already. And it will take some time, even to just bootstrap the portal, right? It's already like probably 30 seconds, right? And portal is still not loaded. So yes, we do that. So going back to regressions, portal runs on the cloud service, and Azure Cloud Service enables you to have 2 slots, one called staging, one called the production. So when we do deployment, we first deploy to our staging slot, then we verify that, okay, portal still loads, everything is fine. Then we do VIP swap, and we still keep the previous version, just in case we'll detect something later on, so we can immediately switch back. Another thing, what all of you should be doing, when there is a bug, the first thing when you're fixing the bug should be writing the test, the unit test, that it's confirming that the bug actually exists. So in your test, you write the actual behavior, make sure the test fails, and then you write the code to make the test green to fix it. It depends, like sometimes I'm doing this, or sometimes I'm just hacking around, do some fix, write the test, and then I'm reverting my change, making sure that it's still failing before, so the test is legit, and then applying my change is green, so I'm sure that this will not happen again. And in addition to unit tests, you also should have integration tests, which in our case are just UI tests. So this shows what happens when you have 2 unit tests, but you don't have integration tests. Might not work. And we also try to have as much unit tests as we can with minimum amount of UI tests, because one Selenium test can take anywhere from 30 seconds to even 1 minute or even more on the CI, because you need to load the entire single page app, which takes time. Then you need to perform some action, assert them. In unit tests, you can run one test in less than a second. So push towards unit tests as much as you can in case of Selenium UI tests. And also our very first unit test is TypeScript, which do all type checks for us. We don't have to write it manually to make sure that API are not broken and so on. And every developer also is struggling with supporting multiple browsers, right? So in ideal world, you will have running your unit tests in all browsers and your UI tests also in all browsers. But this will require you to have bunch of computing power, because in our case, running Selenium tests only on Chrome takes, I think, up to 15 minutes, and we do it in parallel using something like 30 virtual machines. So if we would use this for all other browsers, we'll have to purchase some crazy amount of VMs. So you always need to try to sort of optimize, looking at what's your usages, what's the most popular browser you have. Regarding unit tests, you actually can probably do all browsers. Like currently we run our unit tests in Chrome, in IE, and in Firefox. And we are working on add Edge support as well, because we use Jenkins and the Edge plugins are not yet there. But then we'll add that. And in case of Safari, for example, because we support only the Mac version of Safari, this is harder as well because it will require us to have some Mac server to running them. Plus, I think percentage of Safari users we have something like 1 or 2%. So it's not that much. We still support this browser, but creating entire suite and maintaining it, it's maybe not worth the effort. And of course, the legacy browsers, right? So we are very fortunate because our users are developers. So if you are doing some DevOps and you have IE6 running, that's not a good sign. That's from security perspective especially. So you better even don't run the portal in this case. It's worse when you're running like airline website, right? When some older gentleman just purchased his computer 8 years ago, right? And he just want to purchase tickets to Bahamas, right? So he'll pay you a lot of money, and he bought this machine 8 years ago, and it was fine. Why shouldn't it work still, right? So then you have more troubles into support multiple browsers, and it gets more and more tricky. And recently, we also checked that the Azure portal works on Tesla. So this is my friend Tesla car, and we ran the portal. And it was almost smooth there, so it's pretty cool. But of course, we don't have a Tesla browser in our CI. So going back to the technologies we are using, this is a pretty good stack. I really like TypeScript. With Knockout, we didn't have any significant issues or any performance blockers. Everything was fine. But this stack was chosen over 3 years ago when the project was starting. So now we have new frameworks. And I don't know how many of you have heard about Aurelia framework. Anybody? Nobody? Okay, one person. Whoa, two people only. So you guys need to definitely go to YouTube and check out, because Aurelia is not as popular as Angular 2 and React, because behind Angular 2 you have a Google, you have a Facebook. But if you Google for Aurelia, Rob Eisenberg, who used to be a team member of Angular 2 team, didn't like the direction the Angular 2 was going to, so he quit and he created Aurelia, which I discovered thanks to his blog, because I started following him when he was in Angular 2 team. And then I found out that Aurelia is much nicer framework. You can write much less code, your code is cleaner, and your learning curve is not as steep as in Angular case. And you can also check my Aurelia talk. So if you can see here, I have over 6,000 views, which makes, yes. So now my talk is the most popular Aurelia talk. So that's pretty cool. I recommend you to check out also the Rob talk, because this is more recent stuff. It was 5 months ago. Mine is from over 10 months ago. But I really recommend you to check out Aurelia. That would be my framework of choice for today. And also, Require.js is still cool, but now we have Webpack, which have more features. Like, for example, in Require.js, you cannot concatenate the module names, which sometimes is an issue. You can, of course, work around it, but Webpack is doing it for free for you. Also, Webpack is doing automatic bundling and have some more features. So if you consider choosing the module bundler, check out both Require and Webpack. Also, less is again good, but there's also SAS, which is alternative solution. Both are pretty much the same. The syntax is a little bit different. I think on Stack Overflow, SAS is a little bit more popular, so it's something also take a look at. Regarding unit tests, I would definitely go with Jasmine today, because this framework is more mature. It has the mocking framework and nice assertion library. And we have ASP.NET Core now, so ASP.NET Core 1.0 was released, but you need to be a little bit careful, because we used the ASP.NET Core at the hackathon at Microsoft last last month, and everything was fine until at the very last step. We just need to, instead of using fake data, to use the database that connect to DocumentDB, and turns out that the DocumentDB SDK for .NET Core does not exist yet. So we have to do file new project, ASP.NET, and then add the SDK for standard .NET framework. Another thing, the unit testing, I really recommend XUnit. It's a very nice framework, especially it has the parameterized methods, so you can specify different parameters for your unit test. In Visual Studio Testing Framework, you don't have this, and it also have a much nicer syntax. Instead of MockU, I would go with NSubstitute, which is the richer framework. It requires you to write much less code than you had to in MockU. So I'm running out of time. So at the very end, I want to remind you my Azure tips and tricks videos. Check it out. It's my YouTube channel. Check it out on my blog, jg09.net. And also, you can go to aka.ms/Azure tips and tricks. It will redirect you directly to the playlist. And if you go to aka.ms/Azure portal feedback, there's our user voice. And if you go there, you can actually notice, so aka.ms Azure portal feedback. So if you see here, there's a status dropdown, and if I click it, you can see that we completed over 400 user feedback requests. One might say that we rejected over 202, but more than 100 of these were something like, I don't like the new portal, remove it, right? So of course we have rejected it. And you can also take a look here that the top requests are in status started. So this one is started, this one is started as well, this one is started. So you can go there, you can vote, you can add new ideas, you have nice search here. You can also tweet me at my Twitter, Jacob Jedrzejek, which will be here. You can reach me throughout my blog, jg09.net, and I think there are some evaluation forms, so please fill it out with your feedback. And I hope the stuff I showed you today will be somewhat useful for you. And enjoy the rest of your conference, and please reach me out after my session.